All right, so today you're going to learn about L'Hopital's rule. So we're going to assume that f and g are both differentiable on an open interval a to b that contains c. Assume also that the derivative of g does not equal 0 because it's in the denominator. Okay, then if the limit of the top as x approaches c goes to 0, and the limit of the bottom as x approaches c equals 0, then the limit of the overall function is the limit as x approaches c of the derivative of the top over the derivative of the bottom. Okay, now let's sit right here for just a second. When you did limits, and let's, hold on one second. Okay, we did the limit as x approaches 2 of x squared minus 4 over x minus 2. Well, if I just straight up plug a 2 in there, I'm going to get 0 over 0. So then I taught you a bunch of different strategies that you can use to get out of that pickle. On this one, you would factor and cancel and then reevaluate. Some of them were common denominators and wedding cakes and Bojangles, and some of them were multiplying by the conjugates, and they were huge. Well, L'Hopital's rule says if this is the case, the part that I've written in blue, if this is the case, is if the limit of the top is 0 and the limit of the bottom is 0, then what you can do is take the derivative of the top and then take the derivative of the bottom. Now notice, these are independent from each other. This is not a quotient rule. This is not low-D high. This is just derivative of the top over derivative of the bottom. Then I can reevaluate my limit. So let me show you on this example that I have. So you guys up to this point, and then you would do your limit of what's left, and you would get a 4. Okay, now watch if I use L'Hopital's rule. I'm going back here and I'm taking the derivative. Going here and I'm taking the derivative. And now I'm reevaluating my limit. See how we get the same thing? Now, L'Hopital will only work if the derivative of the top and the bottom are either both 0 or both infinity. So it's called this indeterminate form, which means the form that it's in, I cannot determine what the limit is. So I have to back up and find another plan. And when I taught you limits, I gave you a bunch of different options. Well, L'Hopital says, now that you know derivatives, if you'll just take the derivative of the top over the derivative of the bottom and reevaluate your limit, it'll get you out of that jam. Now here's the cool thing. If you do L'Hopital and you still get 0 over 0, excuse me, or infinity over infinity, you can do round 2 and go L'Hopital again. So you're taking the second derivative of the top and the bottom. You can do L'Hopital until you do not have an indeterminate form, and then pull the trigger on your limit. Here's the word of caution. L'Hopital only works for indeterminate forms. So you can't get L'Hopital happy. You can only use L'Hopital's rule if the limit of the top and the bottom are both approaching 0 or infinity. If it's an FRQ, you have to show that separately. You have to show this and show this separately, not in a fraction. Then you're going to reference L'Hopital's rule, and then you can take the derivative. Now, when you take the derivative, the limit is still there. And then after you take the derivative, then you can pull the trigger on your limit. Okay, let's keep reading. If the limit on the right exists or is infinite, whether it's positive or negative, this conclusion also holds if f and g are differentiable for x near but not equal to c, and the limits are either headed towards infinity or negative infinity. Because again, infinity over infinity is an indeterminate form. Let's see. Word of caution. The derivative of the bottom can't be 0. But that's not going to happen, because if the derivative of the bottom is 0, well, at that number, okay, so if you take the derivative and plug in your limit, try to pull the trigger on your limit, and you get a 0, it doesn't work because the denominator is 0. Then the limit becomes undefined. Oscillating functions, this does not work because you're not approaching a single value. Limit approaches infinity as x approaches c, the limit is undefined. We'll talk about that. We've got some examples for that. Okay, proper notation. Now, there is almost always a L'Hopital's rule on an FRQ. It is not an FRQ, it is a piece of an FRQ. So, you have to explicitly show that the limit of the numerator is either 0, infinity, or negative infinity. Then separately, the limit of the denominator is 0, infinity, or negative infinity. And then you're going to state that it's indeterminate form. Then you're going to say L'Hopital's rule, and you are going to rewrite your limit and take the derivative. You have to use proper limit notation, which is a pain in the butt. It's a pain in the butt. It's a lot of writing. But remember, it's all about that notation and the form. Okay, here we go. Now, I would like to caution you, L'Hopital does not work unless it's indeterminate form. An indeterminate form is when you do the limit and you get 0 over 0 or infinity over infinity. Okay? So, for number 1, if I am plugging infinity into both of these, I can tell that the limit of the top is going to be infinity and the limit of the bottom is going to be infinity. So what I'm going to do is I have to first state the limit of the top is infinity. Separately, not in a fraction, separately, I have to state the limit of the bottom is infinity. Then I have to say that would be indeterminate form. And then I have to say L'Hopital's rule. And then I can do the limit as x approaches infinity of 5x minus 8, 3x plus 1. I'm not going to use equals here. I'm going to use an arrow because one does not equal the other one. One leads to the other one. The limit as x approaches infinity of derivative of the top, derivative of the bottom. Now, the limit as x approaches infinity of 5/3 equals 5/3. Done. Done, 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 done. Okay, now listen carefully. If this is multiple choice, you don't have to write all this stuff out. You need to see it, but you don't have to write it. Okay, you can do L'Hopital's rule, but you don't have to state that you're doing it. It's multiple choice. The same holds true for my test. But if it's open-ended, if it's not multiple choice, then I need to see derivative of the top, derivative of the bottom, stating that it's an indeterminate form, stating that you're using L'Hopital's rule, rewriting the limit, using your arrows, showing L'Hopital's rule, and then reevaluating your limit. Again, small word of caution. Now that you are invoked with the powers of L'Hopital, don't use it if it's not applicable, because L'Hopital does not work unless it is indeterminate form. So use your brain, and real quick, let's look at number 2. If I plug in a 3 to the top, that would be a 0. Plug a 3 into the bottom, that's a 0. Okay, so we're L'Hopital. Here we go. So I'm going to do the limit of the top. And I'm going to do the limit of the bottom. Notice I'm not writing it as a fraction. Indeterminate form. Invoking L'Hopital's rule, which means that the original limit can become, okay, derivative, and then evaluate. All right, so tell you what, I want you to pause it, and I want you to do 3 and 4. And then when you're done with 3 and 4, I want you to hit play and check it real quick. Okay, so for number 3, if I plug a -2 in, that would be a -8, so that's a 0. And 4 minus 4, that's a 0. So limit of the top and the limit of the bottom, indeterminate form, L'Hopital's rule. For 12, -4, -3. Okay. Let's see. Ooh. I can tell easy that on number 4, the bottom goes to 0. The top, however, 25, that'd be 50, minus 45, minus 5. Okay, so yes. So then I would say the limit of the top, and you would write all that out, and the limit of the bottom, and that's indeterminate form. Like, we're already getting tired of writing this, but you have to write it. L'Hopital's rule says the limit as x approaches 5 of the original problem goes to the limit as x approaches 5 of 4x squared minus 9 over 1. Plug in a 5, 25, 100, 81? No. Oh, why is he squared? Sorry. 4x minus 9, so 20 minus 9 is 11. There we go. Sorry. Okay. Headed to infinity. Well, if my powers aren't the same on the top and the bottom, then this is not indeterminate form, because one's going to be getting bigger faster. And it will either be headed towards infinity or headed towards 0. If the top's getting bigger faster, it's headed to infinity. If the bottom's getting bigger faster, it's headed to 0. But these both have an x cubed on top. Now, I know from my horizontal asymptote rules that the limit of this problem is a -1/2. Because I can tell that the horizontal asymptote is going to be y equals -1/2. So as we head to infinity, that's where this problem is going to be drawn to. That's where the graph is going to be drawn to. If this is an FRQ, you can state that. You can state that you know that the horizontal asymptote is y equals negative 1/2. So the limit as x approaches infinity of this thing equals a negative 1/2. But you have to be very careful and very thorough in that explanation. If it's multiple choice, you don't have to do squat. You just have to know those asymptote rules. But if you want to use L'Hopital, which I think is much more clear cut, because we kind of have this form that we just fit, and I know that everything's covered. So I'm going to say the limit of all of that top is going to be infinity. The limit of the bottom is infinity, which is indeterminate form. I invoke the power of L'Hopital rule, and I say that the limit of the original becomes, let's see, 3x squared minus 4x over, if I rearrange it, negative 6x squared minus 6, if I put it in order. All right, here's the problem. If I kick infinity into that, I'm going to get infinity over infinity. So this one's just super fun. So then I now have to go again. So this is round 2. So now I have to state that the limit as x approaches infinity of 3x squared minus 4x is infinity, and the limit as x approaches infinity of negative 6x squared minus 6 is infinity. That is still indeterminate form. So by the power of L'Hopital's rule, the limit as x approaches infinity of the problem that I currently have becomes, let's see, 6x minus 4 over negative 12x. And when you plug infinity into those, guess what happens? You still get infinity over infinity. It's still indeterminate form. So, round 3, the limit as x approaches infinity of 6x minus 4 is infinity. The limit as x approaches infinity of negative 12x is negative infinity. This is indeterminate form. So by the power invested in me by the L'Hopital rule, I can say that the limit as x approaches infinity of becomes derivative, and the limit of a, I don't know, I have a bar right there. The limit of a constant is the constant. Just reduced it. Okay, 3 rounds. 3 rounds on a true FRQ on the AP exam, I think would be a little much. 2 rounds would not be uncalled for. 3 rounds would be a little much. Remember, if it's multiple choice, you don't have to do all the writing. You just do the doing. Okay, so you guys can see this one's going to be the same thing. We're going to do 3 rounds again. But remember, you have those asymptote rules. So if this is multiple choice, I can see that it's going to be infinity over infinity, and they're both cubed, so it's heading there at the same rate. So I know that I can use my horizontal asymptote rules, so I know that the limit, I know that this limit is 5/7. Now, if this was an FRQ or free response on a test, I would have to either state those horizontal asymptote rules, or I would have to go 3 rounds with L'Hopital. So can you guys see on number 5 and number 6, the powers on the top and the bottom are the same, and they're cubed. That kind of tells you how far you're going to have to go when you're headed to infinity. it tells you how many rounds you're going to have to go of L'Hopital's rule. So you can decide if you want to go horizontal asymptote, just be very careful with your explanation, or if you want to go L'Hopital. All right. Oh, number 7 has 2 stars by it. Holy cow. Okay. Oh, I know why. So a lot of people at this point just sort of get the tunnel vision. They're like, okay, let's go L'Hopital. But plug in a 2. You plug a 2 into the top, you get a 16. If you plug a 2 into the bottom, you get an 8. That's not indeterminate form. So I can just straight up take the limit of this. 2 cubed is 8, 8 plus 8 is 16, 2 squared is 4, 4 plus 4 is 8. That limit's 2. Now let me prove a point here. Stay with me on this one. If you did L'Hopital, I'm not going to write it all out, but if I did the derivative and plug in a 2, if I plug a 2 into the top, that would be 4 times 3 would be a 12. And if I plug a 2 into the bottom, I get a 4. Do you guys see how you get a totally different answer? L'Hopital does not work if it's not an indeterminate form. And by not work, I mean it will work. It will produce an incorrect answer. Like you can physically do it, but it will produce an incorrect answer. So nothing in this process gives you a heads up that something's off. You have to check it from the get-go first. So that's what I'm saying. Don't get L'Hopital happy. Okay? All right, number 8. I'm pretty sure I picked number 8 straight off your notes from Unit 1. We're headed to -5. So on top, that would be a 9. Root 9 is 3. 3 minus 3 is 0. And -5 on the bottom would be 0. So this is indeterminate form. So let's pretend we write all that out. The limit of the top, 0, and the limit of the bottom equals 0. So then we say it's indeterminate form, and then we say L'Hopital. Okay, all that stuff's been said. So now I need to take the derivative. So the limit as x approaches -5 of root 4 minus x minus 3. Make sure when you write that minus 3 that it's very obvious that it's not under the root and that the x is. Okay, so there's the original. It turns into, all right, this is 4 minus x to the 1/2. So 1/2, 4 minus x to the -1/2 times -1, that's the duck, and then minus 3 goes to 0 over 1. Well, I know I'm in the clear now because my denominator is a 1. I can plug a -5 in all day long. So here we go. 4 minus a -5 is 9. Then this is going to square root it and make it a 3. And then the negative is going to move it to the bottom and make it a 1/3. 1/3 times 1/2 is 1/6, and that's going to make it a negative. That is for sure simpler than multiplying the original problem by the conjugate of the top. So same thing, number 9. Tell you what, you guys try 9 and 10. Pause it, try 9 and 10, and then hit play. Okay. If I plug in a 0, 4, 2 minus 2 is 0, and 0 on the bottom. Okay, so I hereby declare the limit of the top is 0 and the limit of the bottom is 0. That is indeterminate form. So by L'Hopital's rule, the original limit becomes, so here's where I'm picking up, the limit as x approaches 0. This is 4 plus x to the 1/2 minus 2. So 1/2, 4 plus x to the -1/2 times 1, that's the duck, and then minus 0 over 2. Plug a 0 in. That'd be a 4. Square root would be a 2. Put on the bottom, that's a 1/2. Times the 1/2 is a 1/4. And then if I Bojangles, gives me a 1/8. Okay. If I plug in a 0, that would be root 4 minus 2 minus 0. So that's a 0. And plug a 0 in the bottom, that's a 0. Okay, so I hereby declare that I've written all this stuff out. The limit of the top equals 0. The limit of the bottom equals 0. That is indeterminate form. By L'Hopital's rule, the original limit becomes. Okay, so here's where I'm picking up. But remember, in real life, I'm writing all that stuff out. Okay? So this is to the 1/2. So it would be the limit as x approaches 0 of 1/2 4 plus x to the negative 1/2 times 1, that's your duck. All right, minus 0, that's gone, and then minus 1/4, because the derivative of x over 4, that's like a 1/4 x, so that would be a 1/4, over 4x. Oof, I don't like it. I can already tell there's going to be a 0 on the bottom. Let me see if there's a 0 on the top. 4 square rooted would be a 2. Move it to the bottom, it's a 1/2. Times the 1/2 is a 1/4. Minus 1/4 is a 0. So I would have to go round 2. The limit of the top equals 0. The limit of the bottom equals 0. That's indeterminate form. L'Hopital's rule says that this particular limit right here becomes, okay, limit, let's go again. Negative 1/4, 4 plus x to the negative 3/2 over 4. Now I'm good because the bottom's a constant. Plug a 0 in. Okay, so that's 4. I want to square root it. That's 2. I want to cube it. Now that's an 8. And I'm going to move to the bottom. So that becomes a 1/8. Times negative 1/4 would be negative 1 over 32 over 4. Negative 1 over 128. Good stuff. And trig. Okay, sine of 0. 0. And the bottom is 0. Okay, so in the real world, I would say the limit of the top equals 0, limit of the bottom equals 0, indeterminate form. L'Hopital's rule says that this current limit becomes, the limit as x approaches 0, okay, the derivative of sine is cosine, and the derivative of x is 1. Yay! Cosine of 0 is 1. Love it. Okay, number 12. Bottom goes to 0, that's easy. 2 times 0 is 0. Sine of 0 is 0. So yes, so the limit of the top is 0, the limit of the bottom is 0. That's indeterminate form. L'Hopital's rule says that this current limit becomes the limit as x approaches 0 of 2 minus cosine of x over 1. Cosine of 0 is 1, and 2 minus 1 is 1. All right, more trig. Sine of 0 is 0 over 0. Okay, so again, all the stuff that you have to write, I'm kind of overwriting it all out. Just make sure that for a test or a quiz, and for God's sake, the AP exam, you're writing everything out like you're supposed to. Okay, so limit top 0, limit bottom 0, indeterminate form. L'Hopital's rule says that that limit becomes the limit as x approaches 0 of cosine of 8x times 8 over 1. Cosine of 8 times 0, cosine of 0 is 1. 1 times 8 is 8. Okay. Pi over 2. Well, the top definitely goes to 0. Pi over 2, cosine of that would be 0. Yep. Okay. So top 0, bottom 0, L'Hopital's rule, indeterminate form, all that stuff. this becomes the limit as x approaches pi over 2 of, well, the top goes to 1. Pi over 2 is a constant, so that's 0. And then cosine is negative sine of x, so that's 1 over, all right, pi over 2 is 0, 1. So sine of pi over 2 is 1, and it's negative. So negative 1. Okay, tangent. All right, guys, you get off the unit circle and think about the graphs of tangent. So tangent had asymptotes. Tangent had asymptotes at the uglies. Pi over 2, negative pi over 2, pi over 2, and 3 pi over 2. That's tangent. Cotangents were the pretty ones. Cotangents were 0, pi, and 2 pi. Okay, where am I headed? I'm headed to 0, so I'm not headed to an asymptote. Okay, awesome. So let's remember if that's negative pi over 2, pi over 2, and 3 pi over 2, tangent wiggled up. So at 0, that's the whole point of what I was doing. Tangent, the limit of tangent as x approaches 0 is 0, because the y value is 0. So 0 on top over 0 on the bottom. Okay, so indeterminate form, L'Hopital's rule says this becomes the limit as x approaches 0 of secant squared x over 1. Okay, secant. Well, we didn't graph secant in pre-cal, but you know that secant is 1 over cosine. So now let's go back to the unit circle. So I'm headed to 0. Cosine is 1. So this is 1 over 1, which is 1, squared, which is 1, over 1, which is 1. Okay, headed to 0 from the right. All right, now cotangent has issues. Yeah, cotangent has issues. Okay, so let's look at this one. If I plug a 0 in here, that's going to give me a 0. And if I plug a cotangent of 0, I know I'm headed to an asymptote, so that's headed to infinity or negative infinity. It doesn't matter. The point is that is in indeterminate form. Indeterminate form. So we've had conversations about who would win in a 0 times infinity battle, and it is an indeterminate form. So we're going to take the derivative. We're going to take the derivative, but currently we're not in L'Hopital form. So what I'm going to do, because it has to have a numerator and a denominator, what I can do is rewrite it like that. So I haven't done anything. I've just rewritten cotangent as tangent on the bottom. Now I know that the top is going to be a 0, and the bottom, and we can go back here and see that the bottom, as tangent approaches 0, is going to be 0. So this is 0 over 0. So by the powers of L'Hopital's rule, derivative top is a 1, derivative bottom is a secant squared. So let's see, secant is cosine's buddy, so 1 over 1, which is 1, squared is 1, so 1 over 1, which is 0. Not 0, 1, sorry. All right, 17. Okay, so for 17, if I plug a 0 in, sine of 0 is 0, so that would take the whole top to a 0, and the bottom would obviously go to 0, so all is good. I invoke the powers of L'Hopital, so that limit becomes, okay, If I take the derivative of the top, that would have to be a product rule. But you know, what if I pulled it apart? All right, so before L'Hopital, what if I did a little algebra? And then I separated it. And then I did L'Hopital separately. That would be cosine over 1 positive sine. X equals 0 of cosine is a 1 unit circle. X to 0 of sine is 0. There we go. Okay, so I didn't want to do the product rule. And I could have, no, because if you distribute the sine times cosine, that would still be a product rule. So I pulled it apart. And gosh, I should know these better than I do. But I think these are those the two that we're supposed to have memorized? I think this one for sure is. That one maybe? I don't know. I can't remember. But I can do L'Hopital for sure. So I pulled them apart, looked at the limits, the product of the limits separately, did L'Hopital on one, did L'Hopital on the other, and reevaluated my limit. 18. Ln of x is x heads to infinity. So ln of infinity, okay, so you have to remember what your ln graph looks like. So as x heads to infinity, your y is headed to infinity. So this is infinity on the top and infinity on the bottom, so it's indeterminate form. You would obviously show those very separately. And then state that we're going to use L'Hopital, and then say that it turns into dov over of and a 1. And then evaluate your limits. So 1 over infinity is a 0. Remember, as the bottom gets bigger and bigger and bigger and the top stays put, that that number as a whole is getting smaller and smaller and smaller. So the limit is headed to 0. E, okay, let's remember the graph of E. So E does that. So as we head to 0, E is headed to 1. So 1 minus 1 is 0 over, and then x is headed to 0. Okay, so we're having to remember some stuff. So this is indeterminate form, so that limit becomes, leave it, derivative of the up, which would be a 1, times ln of the base, which would be a 1, minus derivative of 1, which is 0. Okay, so now this is all I have, so now the derivative as x approaches 0 of e to the x is 1. Because I know what the graph looks like. All right, headed to infinity. Well, this is the same thing as this. So infinity on the top and e to the infinity is definitely infinity. So infinity on the bottom. So indeterminate form, I invoke the powers of L'Hopital and derive the top and derivative of the bottom times the derivative of the up, ln of the base. Now I'm headed to infinity. The top's going to stay at 1. The bottom's going to get huge, so 0. 21. All right, again, ln looks like that. We're headed to 1. So that's a 0 minus 1 plus 1. So that's a 0 on the top, and then e to the 1 minus e is a 0 on the bottom. So that is indeterminate form, which you would state. And now I invoke the powers of L'Hopital, and dov over of times ln to the base minus derivative of the x is a 1, and then leave it times the derivative of the up. Okay, now be careful here. E, just plain e with no x's, is a constant. So that derivative is a 0. So the bottom is just going to be e to the x, and then I do my plug my 1 in. Now I get nervous because when I plug a 1 into the top, I get a 0 on the top, so then I think, crap, I've got to do L'Hopital again. But if you plug a 1 into the bottom, e to the 1 is e. And 0 over e is 0. That is not indeterminate form. So I can't do L'Hopital again. So again, I'm plugging in a 1 for my x, so e to the 1, which is just e. So 0 over e is just 0. Okay, now let's look at 22. Headed towards negative infinity. So negative infinity squared is headed to infinity. E to the, that would be positive infinity. Think about the graph. As x heads to infinity, the graph of e is headed towards positive infinity. So this is infinity over infinity. And I would document all that, and then I would use L'Hopital, and I would say that this limit turns into the limit as x approaches negative infinity of derivative of the top, derivative of the bottom is leave it, derivative of the up, ln of the base. And as I head to infinity again, top's going to infinity, and the bottom's going to infinity. And it doesn't matter if it's positive or negative, but the fact is it's still indeterminate form. So I'm going to go again. So L'Hopital's rule, top would be a 2, and the bottom's going to be e to the negative x times negative 1 times negative 1, because I have to do the derivative of the up again. So that would be a positive 1. And now I can head towards negative infinity. So this is now 2 over e to the infinity, which is 2 over infinity, which is not indeterminate form. 2 over a very, very large denominator is headed towards a 0. Okay, and so you guys can see how when they give you just a straight limit problem, they're going to use those tricky functions like e's and ln's and trig to try to jazz those up a little bit. Okay, the top, x is headed to infinity, so the top is headed to infinity, and the bottom, e to the infinity is infinity, and ln of infinity is infinity. And I'm mentally graphing e to the x and ln of x. So just have those in your back pocket and know what those graphs look like. And these should be able to be done without a calculator. So I'm going to say infinity over infinity, indeterminate form. L'Hopital's rule turns that limit into 8x minus 3. Let's see, e to the 2x times 2. Dov over of ln of the base. So the top's still going to infinity, the bottom to the infinity, or e to the infinity would be infinity, plus 1 over infinity would be a 0, but infinity plus 0 is infinity, so we have it again. So I'm doing L'Hopital's rule again. Top goes to 8, that's nice. 2e to the 2x times 2, so 4e to the 2x. This is x to the negative 1, so minus 1 x to the negative 2, headed to infinity. So 8 over e to the 2 times infinity is infinity, and then this is 1 over infinity squared. So this is headed towards a 0. Infinity minus 0 is infinity. And 8 over infinity would be a 0 because the bottom's getting very large. Okay. Things that make you go, and these are great multiple choice questions. The table gives values of a twice differentiable. That means I can take the derivative twice. Use the table to find the limit if it exists. Justify your answer. Okay, so let's just straight up try to find the limit. So f of, let's see, I'm headed to -2. So f of, that'd be -6 plus 2 over -2 squared be 4 minus 4. So there's a 0 on the bottom. And this would be f of -4, and f of -4 is 0. So we have indeterminate form. So I invoke the rules of L'Hopital to turn that limit into the limit as x approaches -2 of f prime of 3x plus 2. Now watch, times 3 because that's the duck, that's the inside, over 2x. Okay, so now let's find f prime of, I'm sticking a -2 in there. So -6 plus 2 is -4 times 3 over a -4. Okay, so f prime of -4 is 8. 8 times, 3 is 24 over -4, which is a -6. Good problem. Use the graph provided to find the following limit if possible. Use proper notation to justify your findings. Okay, all right, we'll use proper notation. Okay, so first I'm going to find g of 3. G of 3 means what is the value of g? It's a 2. So that's a 2. And then 3 minus 3 is 0. So this is not indeterminate form. So L'Hopital's rule does not apply. So I'm going to say not indeterminate form. Therefore, L'Hopital does not apply. So the limit as x approaches 3 of g of x does not exist because I have a 2 over 0. To chew on that, make sure that's okay. All right, 26, home stretch. The differential equation for the curve h of x is given by, okay, so they're giving me the derivative. Given that the original function is twice differentiable, and they've already done it once, and h of 3 equals -1, find, oh dear God, okay. So first, let's just straight up try to find the limit. So let's do the limit as x approaches 3 of h of x plus x minus 2. And then let's do the limit. Like, let's treat this like it's an FRQ. So let's do them separately and see what's going on. So I need h of 3 plus 3 minus 2. Well, that's the derivative. Oh, here it is. H of 3 is -1. -1 plus 3 minus 2 is 0. Should have expected. ln of 7 minus 6 is ln of 1, which is 0. And if you had forgotten that, Think about this. Remember, it's base e, and you snail it, e to the x equals 1, and anything to the 0 power is a 1. So ln of 1 or any log of 1 will always be 0. Okay, so indeterminate form. So I can use L'Hopital's rule. And it states that the limit, again, I'm doing this one full out, of the original mess turns into, so no equals. Okay, turns into, all right, the derivative, well, the limit of the derivative. Okay, derivative of the top. Dov over of. Dov over of times ln of the base, which is a 1. Yeah, which is a 1. Okay, so now I need to do h prime of 3. So to do h prime of 3, I'm going to use the derivative that they gave me there. The problem is he's an x, but it also wants a y. So I need the y value that goes with 3. Well, they gave it to me. It's right there. So that would be 3 times 3 over negative 1 plus 2. It's kind of fun. 9 over 1. So that's a 9. And then 9 plus 1 is 10. Huh. I like it. The bottom, as x approaches 3. Well, that's negative 2 over 7 minus 6, which is a 1, which is a negative 2. So negative 5. Ooh, that's a good problem. I like that one. That's a great multiple choice. Or a part of an FRQ. Absolutely. Okay, 27, last one. Find the limit if possible. Give a reason for your answer. Okay, well, I'm headed to infinity. The top's going to infinity, and infinity to the 99th power is also infinity. So, full out FRQ. So I'm going to tell you what, you pause it. Do all the formality of L'Hopital, and then hit play and see if you get it. Leave it. Derivative of the up times ln of the base. All right. 99x to the 98th. Okay, so 2 to the x, that's still infinity. ln of 2 is a constant. That's not going to do anything to infinity. And now we have 99 times infinity to the 98th power. That's going to be infinity. So we are still infinity over infinity. So I would say that the limit as x approaches infinity of the top, it's still infinity. And the limit as x approaches infinity of the bottom is still infinity. Now, let's think before we turn our wheels on this problem. If I keep going, when you take the derivative of 2 to the x, you will always have 2 to the x. So that will always be infinity. And then x to the 98th, I got to take the derivative 98 more times before this is going to have an x that doesn't have a power on it, or doesn't have an x at all. So this is going to go on for quite some time. So I have to stop. I have to bail out of L'Hopital's rule, because there's no way they're expecting me to do this 100 times. It's not, there's no way. So now let's think about it. I have the limit as x approaches infinity. If I go back to the original problem, and I could stay with this guy if I wanted to, but it's still infinity over infinity. So I'm going to go back to the original problem because it's cleaner. So let's think about who's growing faster. Well, exponential growth is faster than any sort of power growth. So this is growing faster than this one. They are both headed to infinity, but the top is headed to infinity faster than the bottom. So the top is bigger than the bottom. So the limit is infinity. If it was flip-flopped, if the top was slower and the bottom was faster, then it would be headed to 0. And what I have written there, except for the crisscross, what I have written there is enough justification. Maybe you could say growing. You have to show that you tried L'Hopital. You could even make a statement saying, you know, this could go on forever, and then try another tactic and reevaluate it. Okay, the last thing I just want to point back out is when you have multiple choice, you do not have to show all the indeterminate stuff and L'Hopital's rule and it turns into this, like it's multiple choice. But be careful and don't use L'Hopital's rule if it's not an indeterminate form. So even though you don't have to show it, you still need to eyeball it before you commit to L'Hopital. So just be careful because there are some in your homework, and it's L'Hopital's homework, so you would think they would all be L'Hopital's rule, but that's not the case. I'm throwing a couple non-L'Hopitals in there just to keep you on your toes. So just be careful.